For introductions, just, one thing to get out of the way, we had a new hire at Dropbox who sort of said that seem to be sort of like the Jake Wharton of Dropbox. So Jake was really intent on me introducing myself that way in my slides. So here we go. My name is Ryan Harter, the Jake Wharton of Dropbox. Today, I'm going to be talking to you about dependency injection. And what dependency injection? I work with Dagger. That's what I use. But there's a lot of other ones. There's a lot of things out there. And this talk is not going to be specifically about Dagger, but I'm going to bring that Dagger expertise of mine to this talk. The idea here, the idea for this talk came because of a common refrain that I've heard people say, and that is that Dagger is complicated. And I get it. I understand the sentiment, especially if you haven't been through, early, Dagger 1 dependency injection, Dagger 2, and then Kotlin came along, and then we had Coin and, a few others. There was kind of all this stuff in the Android ecosystem along the way. Coming in later, it can seem really complicated. But what I'm here to talk about today and to share with you is that Dagger's not the thing that's complicated. It's really dependency injection that is complicated. The concept of dependency injection itself. And as a quick aside, in 2023, I gave a Dagger talk in London, and my idea there was that I wanted to share some concepts. Like, here's what Dagger's doing under the hood. It's not really all that complicated, and it's the same thing that you would do if you were writing a dependency injection system yourself. And I gave that talk. It was a lot of fun. My first time to London, and a friend of mine, a colleague at work, was sort of using some of those concepts to write it up. Thank you, John. In some documentation at work, and asked me to review it, and I did that, and I realized, well, this actually assumes that we have a shared language and understanding of these even more basic concepts. So over the last 5-10 years, I've been giving these talks about Dagger and dependency injection, and continually kind of going like, okay, we need to get more into the basic concepts of separate Dagger from it and just dependency injection as a whole. And so that's what this talk is about, is to share these basic concepts. There's, as a whole, there's 5, 6, 7 like basic concepts that if you understand those, it's just puzzle pieces you put together. And so we're going to start that with some standard diagrams, just sharing the idea of dependency injection. So you might have seen diagrams like this. We start out with some sort of class. In this case, it's my presenter, and it depends on some sort of external class. In this case, maybe like a repository. Your presenter is pulling data from your repository in order to provide things to your UI. That's pretty straightforward. There's other dependencies that this is going to have as well, and those might be some other types, another repository, analytics, something like that you need to use. And these are where a lot of the basic intros kind of stop. Look, I have one dependency, I'm giving it to this. But the story's, of course, bigger than this, right? These dependencies in and of themselves have their own dependencies. So your repository might depend on an AI, a database, and then those dependencies are going to have their own dependencies, and then it kind of makes this big chain, this tree, and then some of these earlier dependencies also have their own things, and then we've got other stuff over here, and then, of course, especially in the Android world, we love our contexts, and there's always some sort of dependency that just everything else depends on. And so really, at the end of the day, outside of this really basic, 2 or 3 or 4 class example, this is what we end up with as a dependency tree. And this, if you've built any sort of apps, not even at like super scale, but just any sort of apps that are scaled enough to ship to somebody, this is even a simple example. Dependency trees get way more complicated. And so this is what I mean when I say that it's really dependency injection that is complicated, just through the scale of things. So we're going to dive into these basic concepts that we can put together. And I'll share with you a little bit about the sort of general language of these concepts, and then sorry, this silent conference isn't all that silent. So going to share these basic concepts and some of the language that they choose to use in Dagger specifically. Some of the other libraries sort of have their own language for things, but these concepts are general and they apply to all of them. And the first one we're going to start out with is the object graph. When I'm working with engineers at work, an engineer comes up to me and says, hey, I'm getting a compile error with this esoteric error string. I don't understand what it means. And 98% of the time, it means that some dependency is not available where you think it is. And so my response is always, okay, where is this provided to the graph? Or where is this on the graph? And a lot of times people will look at me and say, the graph, what is the graph? And so the graph, in simple terms, is that diagram that we just looked at. This is the object graph. What dependency injection frameworks and libraries do is they basically build up a graph in the mathematical sense of nodes and edges and directionality. In this case, they build up a graph of all of your dependencies, and that's why at compile time, if something's missing, you have some dependency that it can't find, it'll tell you that. It's able to do that. If we back out for this illustration to the super simple illustration, I want to take a look at how does this pretty diagram with these pink boxes, how does that map to code? And so with this simple diagram here, we have my presenter and it has a few dependencies. And what you'll see there is maybe code that looks like this. We've got some private or not properties within our class. And the important thing here is that we have these external classes. That's what identifies, that's the red flag that says, hey, these are dependencies. And this example right here is actually not dependency injection. This is a naive, simple way to take this approach. We'll talk a little bit later about how this can kind of be hard to see, can be a bit of a masked problem. But in this case, we're instantiating these objects right in here. But that doesn't scale. That's going to break down really quickly. Not only is testing difficult, but also just knowing how to instantiate these objects. If you remember that full graph that we saw, these objects have their own dependencies. We need to know where to get them, how to configure them, all of that information. So what we can do to make this not dependency injection, to make it dependency injection, is just simply make those constructor parameters. And that's it. At this point, what we have is dependency injection. It doesn't use Dagger. It doesn't use Coin. It doesn't use Metro or any of the other dependency injection frameworks. But this is dependency injection right here. The idea that instead of creating the dependencies within the object or the subject that's going to be using them, you pass them in, you inject them. So pretty straightforward here. And what we're doing is those same dependencies that we define and we inject there are identified here. They're passed in, and those are external classes. And what you'll notice is if we map this out, this actually maps really closely to that diagram that we saw before, right? We remove the boxes, we write it in code, and that's how we conceptualize the concept of dependency injection. So now that we have this, what do we do? This isn't a system in and of itself, because every time you want a presenter, my presenter, you would have to have these dependencies and pass them in. Well, a simple approach, a naive approach you could do is just use Kotlin's default parameters, and you could pass those. That's really, at the end of the day, the same problem as before. It allows you to override dependencies in tests, but the complexity of building these dependencies is still there. So instead, what we often do is make factories, a factory function. If you've used, if you've been in the Java ecosystem for a long time, you are probably very familiar with factories and factories and all of that kind of stuff. So a factory function that the implementation of which knows how to construct these dependencies, and consumers can just call get my presenter. We might put that in an object. That object we could just call object graph, for a lack of a better term, and there we have our object graph. Now, where do those dependencies come from? Those transient dependencies? Well, they can just be part of that object graph. So the object graph is the thing that sort of ties everything together, knows how to build things. And then it's really easy to see from here how we get that implementation to be able to do that. We simply use that constructor that we had before. We call the myPresenter constructor, and we use those other factory functions internally. And that's how we construct in code our object graph. Now, whenever we have an object graph, there's always some dependency we need in order to bootstrap this, right? If we were writing static code that never changed or adapted to the environment or to the platform or anything like that, this wouldn't be an issue. We wouldn't need dependency injection. We would just instantiate everything directly inside our classes. If you're familiar with Android development, this might be an application or the application context. There's always something we need. And so we might, some sort of like core dependency, we might diagram it with like that green box there, something that we can't construct, we have to provide. And so if we go back to our simple implementation of the object graph, how would we do that? Well, in this kind of scenario, it's really straightforward. We could just add it as a constructor parameter to that object graph. And then simply we have something like the application on the graph. And so now it is available for these other dependencies. Maybe our analytics needs to write a database. It needs to be able to get access to the file system, and it uses the application context for that. So now we have that available on the graph for use. In Dagger, if you're using Dagger, this object graph, this whole concept is called a component. Why is it called a component? I don't know. The Dagger engineers apparently wanted to come up with a new name that was not standard, and then people had questions about it. But what's interesting about this component, object graph, I think in Metro it's called a dependency graph. They're all the same thing. They're basically the place that contains and from which you get your dependencies. But you'll notice here, this is just a standard object. In Android, we often want a place to where are we going to store this? How are we going to get access to this to be able to get things out of it or use it to instantiate new items? Well, this is just a standard object, so you have to store it somewhere. A lot of times we use the application to store it. If you use something like Hilt with Dagger, it's not really doing a lot of magic under the hood. What it's doing is using a persistent fragment that doesn't react to configuration changes and that kind of stuff. And that's how it started out. Now it's actually using the view model store. So it has a view model that is able to survive the lifetime of the app that just hangs on to your object graph. And that's how it does it for each of the scopes going down. So that is the object graph. That's like the most basic fundamental concept in dependency injection. This is shared by all dependency injection frameworks that I know of. Quick caveat. They all have a dependency graph that they use. One thing that we lightly touched on, and the next sort of basic concept that I want to talk about here, is the idea of a factory. So dependency injection frameworks, at the core of what they do, assemble an object graph and generate factories for you. So if we go back to our myPresenter here, this is pretty straightforward. We could embed all of the code to construct this presenter directly in our object graph. Things get pretty unwieldy pretty quickly, and it gets challenging when we have modularization and that kind of stuff. So instead, what Dagger does is generates factories. In this case, just prepend the the my presenter onto your factory, and you can generate a my presenter factory. And what is that factory going to do? It's going to have a function that is simply a get function, takes no arguments, and spits out a my presenter. So this is pretty straightforward. That's our function. And then since Dagger's generating factories for effectively everything that's available on the graph, with some hand-wavy optimizations aside for inlining, but for anything like real or complex, any inject annotated constructors, you're most likely going to get a factory generated. It takes in just factories for those dependencies as well. So it's factories all the way down. We'll see why in a little bit. But to start this out, you can see based on the code we wrote before, it's very simple. All we do is call get on those factories for the dependencies and just pass that to the inject annotated constructor. So at the end of the day, this is really simple. This is a factory you might write. And what Dagger does for you is take the boilerplate out. What Metro does is take the boilerplate out. Now, all of these have their own factories, and they're all very similar, look almost the same. And so this is a Daggerism here. What Dagger does is, actually not what Dagger does, what JSR 330, which is the, it actually came out of the Juice era, it's the Java standard for dependency injection. It's not a dependency injection library, but what it does is it provides standard pieces that any dependency injection framework can use. So Guava uses the same annotations or components out of JSR 330. Spring, Dagger, like all of these others. Things like add inject and those. In this case, what we have is we have a provider interface. I wrote a blog post about how elegant to me this provider interface is. It's so simple, it looks like something that shouldn't need to exist. A provider is something that just has a get function and returns some object. Super simple, but immensely flexible. And we'll get to that in a minute. When Dagger's generating stuff, the factories that it generates are actually instances of a provider. When you're using Dagger, you can inject these dependencies directly. You can also inject the provider, and what that allows you to do is call the get function and get an object. So if you want to do things like, you don't want to have to resolve the dependency, not resolve, to instantiate the dependency unless it's needed. Maybe it's an expensive object that, only if a user taps a certain feature or something, are they going to need this. You could inject the provider, and that basically delays the instantiation. It's another way to get around race conditions if you have not exactly circular dependencies, but semicircular dependencies, which you shouldn't have. So that's what we get. That's the provider, and then all of those factories are also providers. So within Dagger and other dependency injection frameworks, it's not factories all the way down, it's providers all the way down. So that's the core of factories. And that is, outside of the object graph, that is kind of, in my opinion, the primary thing that any dependency injection framework is doing for you is generating factories. And if it's not, it should be, because that's a pain to write. Next up, I'm going to talk about object lifetime. And so if we go back to this, this presenter, this is a really simple provider. All it does is every time you call get, it's going to instantiate a new presenter and give it to you. That's really simple and straightforward. But if we look at the specific dependencies it uses, there's one that stands out, and that's analytics. Analytics is kind of special. And it has its own factory or provider. This is the point where we get I added the Dagger provider bits yesterday evening and did not update the rest of my slides. So just imagine this implements the provider interface here. If we look at the analytics, what it's doing here, a lot of times when you're recording analytics events, you want to have some sort of way to tie events for a user together within a session. And so in my case here, I'm using a session ID. A session ID is just a string, and it's going to be random. So the idea is that every time you start up the app, you get a new session ID. That is like internal to the analytics, something that only the analytics really needs to know or care about. There is kind of a red flag here that I hope you can identify. We'll come back to that in a little bit. But the analytics has a session. And so if we take our simple implementation of the provider and we just construct an analytics when you call the get function, what is that going to do? Well, we may get an instance of that analytics factory, and then we call get on it, and we get that session ID, and we get some value. That's as expected. But now, if we call get, which happens every time you inject a dependency, so if we get a new dependency injected and we call that session ID, we're going to get a different value. And that breaks the whole point of a session ID. Because what this is doing is this is instantiating a new analytics object every time you call get. So, how do we fix that? Well, instead of doing the simple approach, we need to implement stuff in here. The factory itself can maintain an instance, and we need to make that instance any. That's sort of a JVM-ism, and the reason being is that providers can return nullable or optional types. Once it gets compiled down to bytecode, nullability is kind of lost, right? Everything can be null in Java. So we can't use null to mean there's nothing, like an instance hasn't been generated, because then if something's supposed to be returning a null, the next time we want to provide one, we do the computation again because we don't know. So we'll have some sort of like none object that represents we haven't computed this yet, and we simply set our any to that. And then it's pretty straightforward. Within our get function, we just check to see if that instance equals null or none. There I go, Java programmer at work. And if it equals null, we create our instance of analytics, and then we simply return that instance with a little cast in there that this is all generated code, so it's not really dangerous. This is the concept of what Dagger generates for you in certain circumstances. This is not the actual stuff, because what we really need to do is we need to know that this is type-safe code. So there's going to be some double locks and type checking in there and things like that. But for the most part, this is basically the concept of what we're doing here. And now we do that same thing before, and we're going to get the same value because those instances that are returned from the get function are going to be the same. And so this, going back real quick, one of those things that didn't make it into the slides. In Dagger, this is just a provider, again. And what's important here is that all that logic around like should we create a new instance every time or not is all contained within the factory, right? Consumers, the classes that are going to have this injected or that are going to be using this, they don't have to know or care. They don't have to say, hey, get me the shared analytics, not the new analytics. And analytics itself does not need to have any of this complexity around, if I've already instantiated, I'm going to have a singleton in this case, but maybe there's some cases where I don't have a singleton. We sort of extract that out into the plumbing, which means that the code that we actually are writing is able to be simpler. It's easier to test. A lot of the edge cases are now contained within this generated code. And we'll just skip ahead a little bit. So that is object lifetime. Now going back, I mentioned before that there was a red flag in here when we looked at this analytics implementation. And I hope you all found it. But basically right here, when we look at this session ID, you'll notice this is calling a function, not a constructor. But this is another case where this is a dependency. It's not a class that's performing business logic or anything like that, but even strings can be dependencies. So really, we should be injecting that into our analytics. And the reason being is that if we do something like this, then all of that complexity around we want to get the same analytics instance, that actually kind of goes away. We want the same session ID instance, but we don't necessarily need the same analytics instance every time. This ends up actually being quite tricky, though, and requires another basic concept that is qualifiers. So, qualifiers are something, I don't actually know if there's a general term for this in dependency injection with lowercase d. In Dagger, we call them qualifiers. I believe that qualifier is part of JSR 330 as well. But the problem here that qualifiers solve is that as we've been talking about all of this, what I've been using to sort of relay the idea of the object graph and how things tie together and all of that is the type, right? The type of an object. In this case, we have a string. Well, I'm sure you can see the challenge that lies in there. This is the diagram where we're actually using the type to declare everything on the object graph. And that makes it so that it doesn't matter what you call a variable. You don't have to provide extra code. You can just write normal code. And we use those types. Our analytics now depends on a string. That's straightforward, no problem, except other things might too. So like our API might have like an API key that is a string. And if we're using just the type to differentiate types and put together this object graph, well, now we have a problem. We have a conflict in the object graph. So what do we do to fix that? Well, we effectively, what we do is we just add a tag, some sort of differentiator. In this case, we'll add tag 1 to our session ID string, tag 2 to the other one. And that now means that the tag and the type go together, and those are sort of the dependency ID when we're constructing a graph. And so that's how everything fits together. But what I think is clever about Dagger in particular and other libraries that have come before it is there's a lot of complexity here. When I'm looking at tech specs or anything like that, the idea of having, okay, for most items, we're going to use the type. But for these special cases, we're going to use this special thing where it's a tag plus the type. And how's that going to manifest itself within the code? There's a lot of complexity. But if we go back to that null problem that Java's always had, we can actually use that. So secretly under the hood, if you don't add a qualifier to some dependency, Dagger is going to do it for you. It's just that the qualifier is null. And that is a valid, like the lack of a qualifier is in itself a qualifier. And I don't have a slide for it here, but what that means is that you can also have, only one of those two strings really requires a qualifier because the other one has a null qualifier. And so they're differentiated. So what does that end up looking like? In Dagger, Java, Kotlin, most of the dependency injection frameworks there, the way that this is done is using an annotation. In this case, we created a custom annotation called session ID. There's also one, I believe, called named, where you provide a value to it, and the named annotation with that string value. The string value is actually the discriminator there, the thing that identifies it. So instead of using the type to define our dependencies, it's actually a mixture of qualifier and type that go together. If you were writing your own dependency injection framework or tools, you might represent that with something like this. What did I call it late last night when I renamed it from type, because that was real confusing. Dependency ID is what I called it. It's a nullable qualifier. Again, where null has meaning, doesn't mean that, we ignore it. And then the class, which is the type of dependency we're talking about. And as we build up that object graph that we talked about earlier, we need to take an inventory of all of our dependencies so that we know how to provide them. We might do that with a map. And that map could be a dependency ID to provider, that factory. And in this case, for analytics, what we put in that map is the session ID and string, which is our dependency ID together. And we map that to our session ID factory, the implementation of the provider for it. And then we also have the analytics factory. And here's where you see the dependency to null and analytics. And now what we're able to do, what Dagger does, this is a bit hand wavy, it's not just a map that it throws together, but effectively what it does in the compiler stage, you get an error that says, hey, we've got a conflict on the graph. Effectively what's happening, it's trying to insert something into this map, and if there's something already there at that key, dependency ID, then it stops and says, hey, here's a conflict, you need to resolve this. So that's where qualifiers come in and how you use them to disambiguate shared types. All right, we're going at a breakneck speed here. We've got a bit of time, we're doing all right. So next up, we're going to talk about child graphs. We talked about the object graph before. This is what it looked like. Just all of our dependencies, how they connect together, and then we've got that green one up there, which is something that we provided externally. And in our case, that thing up there, I think it was an application instance, like the application context in an Android app. That's something that we needed to provide in order to bootstrap this entire graph. It's sort of a core dependency. Well, in a lot of cases, we have other situations like that, but they're not needed for the entire graph. We might have an external piece of information that's needed. Let's call it this blue guy over here. And maybe it's something like a user ID, right? Now, when your app starts up, you maybe show a login screen, right? You still need dependency injection for that, but you don't have a user yet, right? Your API that represents a user can't be instantiated at that point. And so that section is not part of the main graph that we're going to be using for all of this. But that dependency also means, that user ID means that without it, we can't instantiate this thing on which it depends, or these other items that are sort of down the tree. And that just keeps going all the way down. So in effect, what we have here is we have an entirely separate graph that the section on the right, we can construct that graph as soon as we have our application, that green box up there. But that entire graph on the left, while it is related to and sort of, I don't want to say part of, so we'll stick with related to that main graph, it's actually kind of its own thing because it has some sort of external dependency that's not always going to be available. But it does depend on things in this main graph. Now, using standard object graphs, components in Dagger, we can do that, right? We can build this as a separate graph, an isolated thing, and all we have to do is take all of these dependencies, throw them on the factory, so we provide all of those to that other isolated component. But that doesn't scale. Then we want to add anything over to that blue section, and we've got to go figure out the dependency over there. We have to add an accessor so we can get it out of that other graph. We have to add it to the factory. And now we're just writing our wiring code by hand again. So what Dagger does, Dagger calls these subcomponents. You have your components and you have your subcomponents. I believe in Metro, they're called dependency graph extensions or extension graphs. You're extending that main graph with some other graph. So if we go back to our code just to see, in code, what does this look like? We have our object graph here. I changed out the dependencies we're exposing here just for the example. So these aren't exposed. These are internal to the object graph. We have a network client. We have analytics. That's great. And then we want something, let's say a user API. This is the thing that's going to hit the REST endpoints on behalf of the user. And that has some standard dependencies, the network client and analytics. And we can see those are available on the primary object graph. So that's great. But we also need some way to identify the user, like a user ID. In this case, it's a string. It uses a qualifier like we just talked about. But that's not available on the main graph. It wasn't there when the application started up. So what can we do? Well, one option is to add a factory function to that object graph in which you provide that user ID, and it will use it to construct a user API that it spits out. This is a simple solution, but this breaks down really quickly. And the reason is that, as we saw before, dependencies have dependencies kind of going all the way up the stack. And so it's probably not your product feature code that's going to be using this API. It's probably a repository that your feature code uses. So now does your feature code need to figure out where a user API is, get it, pass it to the repository that can then pass it here? It gets real complicated real fast. So that's out. But what we can do instead is we can take a tip from before, where that top dependency is actually just like the green one before. That's something we need to provide. And once that's provided, we can build this entire graph. So in order to do that, we can take our object graph, which again is just a class or an object, and we can make an inner class of that called child graph in this case. Might be a user graph or anything else. And that's going to have your user ID. And then internally to that, since now it has a user ID, just like the main object graph, it's able to use that user ID to construct the dependencies that it provides. Additionally, since we made it an inner class before, it's also able to access the main object graph. And that is effectively the key here. How do we get one of those? Similar to anything else, we can create a factory function on the main graph that knows how to construct this. Now, internally, when Dagger does include subcomponents as they're not inner class, or they're not Kotlin inner classes, they're Java inner classes, but it does include them in the main component, and it exposes these factory functions which you might provide. And this will say, just like any other dependency, give me, I'll give you this extra piece of information and you give me the thing. The child graph is really a dependency like anything else that the object graph knows how to construct. So once we have that, all we have to do is in our app code, we use our object graph wherever that is. We call that factory function. We're able to get an instance of it. And then from there, we're able to get those child dependencies. And so that is child graphs. Again, in Dagger, they're called subcomponents. And in Metro, I believe they're called extension graphs or graph extensions. And I would, if y'all are using Dagger, I'd highly recommend using those over the sibling component approach, because it just takes all the boilerplate away. So at the end of the day, we covered a few of these like basic concepts. They're not specific to Dagger. They're not specific to Coin or Metro or any of these other things. But hopefully, by understanding these concepts, I've been able to sort of highlight how the tools themselves are relatively straightforward, but the complexity comes when we're trying to construct these things of these massive scale. But once you have a good understanding of these basic concepts, then it kind of all comes together, and moving even between these is a lot easier. So these concepts we talked about, the object graph, factories, the object lifetime, qualifiers used to disambiguate dependencies, and then child graphs, which was really kind of the end. And with that, I'll leave you. If there are any questions, I think there's 4 minutes or so. I'd be happy to answer them. Otherwise, in the hall, in the same area on the side. But thank you very much.